So here we go. So all right. So I'm just basically gonna do homework with you. That's what I do. So about half of them or so. We'll try to do one of every type. So all right. So they're giving me that graph, showing me the numbers between 5 and 7, and they're asking me to use interval notation to describe it. Now, what is interval notation? That means like bracket or parentheses. I'll explain the difference in a minute. Left edge, comma, right edge. So interval notation means like brackets or parentheses, left edge, comma, right edge. So in other words, as we look up here, what numbers are shaded? All the numbers between 5 and 7, that's what we see on the graph. All the numbers between 5 and 7 are shaded. So my interval notation is just that. It's just 5, 7. Because 5 is the left edge and 7 is the right edge. It's that simple. That's part A. And then in part B, that's the part A answer. In part B, they're going to want me to write it as an inequality. Basically, I'm saying in this problem, I'm saying the same group of numbers, all the numbers between 5 and 7, in 3 different languages. That's basically what it's like saying 1, uno, and 1 in some other language. I'm saying all the numbers between 5 and 7 on a graph with an interval notation, and now with X's and like greater thans and less thans and things like that. So how do I say the same group of numbers, all the numbers between 5 and 7, with X's, greater thans and less thans? How do you say that?
X is greater than or equal to 5 and less than or equal to 7.
Yeah, the X is the shading. So whatever you say about X, you're saying about the shading. So the X is the shading, and the shading is between. Anybody find a hat sitting somewhere?
No.
Sorry, I don't think so. So X is the shading between 5 and 7. So you put the X between 5 and 7. And how do the symbols go? So the X, the shading, is between the 5 and the 7, right? So I put the X between 5 and 7. And which way do the symbols go? How do you logically say X is in the middle? When the shading's in the middle, the X is in the middle. I mean, with the symbols.
So X of 5 is less than X. Yeah.
Both less than. Yeah. Does that seem right to you? It is right, but let me help it seem right if it doesn't.
Wait.
It's because this is this. It's kind of like ordering a soda. Small, medium, and large, right? The X is the middle, so he's the medium. Isn't it true that the small is smaller than the medium and the medium is smaller than the large, huh? So that is the right way to say middle. Both less than like that. It's like going from smallest to biggest. Good? So there's the 3 answers. Or the 2 other answers they want. We just said the same, all the numbers between 5 and 7 in 3 different languages there. It'll be different numbers. And it doesn't mix up the order. The order is the same as well. It's just different particular numbers. So now we have shading. I don't know if it's big enough for y'all to see. Let me put it up here. It's right here. And the shading, notice this time the shading has an arrow going to the right forever. It's a little bit different than the last one. Look at the last one. The last one had brackets on both ends. It stopped at 5 and 7. But this one has an arrow going to the right forever. So it looks like it starts at 7. It's right between 6 and 8. So 7. And goes to the right forever. So what is right forever? How do you say right forever?
0.9 bar.
It's infinity, right? Right forever is infinity. If something goes left forever, that's negative infinity because the negative numbers go to the left. Good there? So, okay, so what would be our interval then? Remember, it's always left edge, comma, right edge. So that would simply be 7, comma, infinity. Oh, and let's talk about brackets and parentheses now. Do y'all know the difference between a bracket and a parenthesis and what they mean?
No, I don't. Parenthesis means it's included, and a bracket means it stops there.
So bracket means you're straight on that number. So let me write that. So bracket, they have straight edges to them. You include the endpoints. Parentheses do not include the endpoints. So in other words, let me be super clear here. When they put a bracket 7 to infinity, what they're saying is 7 and any numbers bigger than that. If I put parentheses 7 to infinity, that would mean 7.0001 and everything bigger, but not 7 itself. Not 7 right on the money. Does that make sense? So a parenthesis, here maybe this helps. It's rounded, so you're around the 7, but you're not right on the 7. And a bracket, it's got a straight edge to it. You're straight on 7. So this would mean straight on 7 to infinity. This would mean close to 7, but not quite all the way to 7. Parentheses do not include the endpoints. Okay, so there is the difference on that. Now, why do I put a parenthesis next to infinity?
Because it goes on forever.
Yeah, you can never be right on infinity, huh? It can seem that way, but you're never straight on. You can go to the doctor and say, I felt like I waited forever, but you're never right on infinity. You're just going towards. So we always put parentheses next to positive or negative infinity because you're never straight on infinity. So there's our answer on that. Now, how would we say that with an x? That we need the third language. We have the graph. We have the interval notation. Now we need to say it with an x, greater than, less than kind of thing. So remember, what you say about x, you're saying about the shading. The x is the shading. So we put the x up there. The x is the shading. So what's true of that shading? What's true of it? Now, you might say, you might think, well, can't we just put it between 7 and infinity like that? Well, yeah, that's true. For whatever reason, we just don't write it that way. When one of the numbers is infinity, we don't write it that way. Even though we do for interval notation, we put the infinity there, sure enough. But we don't write it that way. We just say x is greater than or equal to 7. Because that's a simpler way to say the same thing. I guess that's why we do it. X is greater than or equal to 7. Isn't that right? Because x is to the right of 7, huh? And to the right means greater. Greater things are to the right. Smaller things are to the left, aren't they? So to the right is greater. X is greater than 7. It's to the right. And we're done. Is that good? Now, if it had parenthesis, 7 instead, what would I do different with the greater than or equal to? Get rid of that equals, huh? Everybody see that difference? Because if it had a parenthesis, then it would not include the 7 right on. So I would have to say just greater than 7, but not equal, not 7 right on. But they had a bracket, didn't they? Come on. They had a bracket, so I make it greater than or equal, because you can be right on the 7, you can be equal to the 7. So the brackets always go with the bars, if that helps you. BB, bracket with bar, always. Parenthesis, no bar. Okay, x is less than negative. So in these first 8 or 9 or 10 problems, they're just going to give you like a graph, or they'll give you an inequality. They'll give you one of those 3 forms and ask you for the other 2. They're just making sure you can change easily between the forms. So how about, first off, can you write that as an interval and a graph? It might be easiest to do the graph first, whatever you want to do. I found it's easy to do this. Yeah, how about I do the graph first? So put that on the graph. Remember, the x is the shading. So what you shade on the graph should be what's true of x. X is the shading. So put it on a graph, and then go ahead and write the interval notation with left edge, right edge kind of stuff. Okay, so -2, and the shading is left. Why? Because x is less. Less means left, doesn't it? Right? Lesser numbers are to the left, right? -3, -4, -5 to the left. Good so far? And the parenthesis, why parenthesis instead of bracket? Because there's no equals bar, right? The bracket goes with the bar, no bracket, parenthesis, right? Because we're not including the -2, are we? Just things less than -2, like -2.1 and stuff. Yeah.
So you're going to put that on the line?
Yeah, well, I'll show you. I'll show you what it looks like on Math Excel in a minute.
Oh.
Let's now do the interval notation, then I'll go back and do the whole thing on Math Excel. So now, how would the interval go? Remember what interval notation is? That's left edge, comma right edge with like parentheses or brackets or whatever. So what's the left edge of that shading chunk? This shading chunk. Negative infinity, yeah. So it's going to be negative infinity, which always gets a parenthesis because you're never right on that, and then negative 2. So there's the interval. Making sense?
Why is there no bracket?
Yeah, because there is no bar.
Oh, okay.
Yeah, so the bar would go with the bracket. Because the bar means equal, you're right on the number, so that would be bracket, you're straight on it. But if there's no bar, you're not equal, then there's always parenthesis. So yeah. So, okay, so we have minus 2, 2x minus 7 greater than 18. All right, go ahead and solve that. There's a little trick about halfway through. Don't say it out loud. Give everybody a chance to remember it. See if you remember. So start by distributing. Just want to solve for these. Want you to get x alone. Just want you to solve for x there. Get x alone. They've got all the multiple choice answers already there.
Hope that's a CC second. It's been a long summer. Oh,
Boom, boom. So minus 4x plus 14 greater than 18. Good so far. So what's next? If it helps, you can put a wall in, separate. Yeah, X is saying I want to be alone. That's what X is always saying. I want to be alone. So yeah, get rid of the 14, huh? I'm sure you remember all that. This is gone. Minus 4x greater than 4. Okay, now, last step to get x alone. What do we do to get x alone? Divide, yeah. Why can't I just add 4? Because it's multiplied, right? Because there's no symbol in the middle, it's times, you got to divide, right? So divide by negative 4. And?
Negative 1, but you have to flip.
There it is. Did you remember the trick of flipping the symbol? That's what I imagine a lot of you did. Just got to flip symbol, so let me just make note of that. When you multiply or divide by a negative, when you multiply or divide, multiply slash divide, by a negative, you must flip the symbol. So you've got to turn it. So right there, I turned it the other way. And 4 over negative 4, that's negative 1. There's my answer. So that would be one of those answers there. Is that good? Do you remember that trick? So when you multiply or divide by a negative, you have to flip the symbol.
So,
Right? Because when I put a negative down below, got to flip symbol. Yeah, which answer is it? A, B, C, or D? C and D both look right at first, but only one of those has the
you're not
right.
gonna have any brackets because it's not equal to
Yeah, there's no bar here, huh?
Yeah.
So there's no brackets, so it's C actually, not D. C has, I don't know if you can see it, but C has the parentheses. So C is the right answer on that. Rebecca.
Can you explain why you flip it? Is it quick or would it take a long time?
Yeah, no, I want to talk about that. Everybody good, those steps? Yeah, why do you? I like that spirit of why, and let's talk about it. Yeah, because I don't want math to be like magic to you. Think about, what if you had like 2 less than 6? That's a true statement, right? 2 is certainly less than 6. And what if you divided both sides by like negative 2? Now, not that you would necessarily or whatever, but just what if you did that and you didn't flip the symbol? Watch how you would get something not true.
not true.
That'd be negative 1. That'd be what, negative 3? Now, on the number line, that's not true, is it? Because here's 0. Here's negative... No, that's not negative 3. That's negative 1. I'm making it true. And there's negative 3. Yeah, so negative 1's actually the bigger one, isn't it? Right? Right? Have you ever been in debt? I've been there. $1 in debt's better than $3 in debt. This is more, isn't it? So, and this is saying the wrong thing. It's saying minus 1 is less. That's not true. So you can see it's just a matter of truth. You have to flip the symbol when you divide by a negative or you'll lose the truth. All right, so that's why we do that. really, generally what I think is easiest, you don't have to, is just get rid of them. I would not distribute that 1/4. I mean, you could, there's nothing wrong with it, but I think it'll be easier, instead of distributing that 1/4 right now, is just to get rid of it.
Multiply by 4.
And what'll do that is multiplying by 4, huh? Yeah. So that's what I would suggest is the easiest way. Multiply by 4. But now here's the $1,000 question. Do I multiply by 4 there? Do I also put it there and there? And I definitely need it on the right side. That's 4 there and a 4 there. Do I put it on the x and the 6? No, you actually don't. Why not?
Because you're going to just distribute the...
Yeah, because whatever you do to the outside distributes, huh? Yeah, if you did it, so in other words, whenever you have parentheses, and you have to do the 4 to everybody, you got to do equal treatment, right? That is the idea. If the left side is bigger than the right side, that's what this says, left side bigger than right side, and you treat them the same, then the left side will still be bigger. That's the principle that we're all following, right? If one side's bigger than the other and you treat them the same, it'll still be bigger, right? So I got to treat them the same. It's true, I do. I need to treat them the same. Whatever I do on the left side, I got to do the same thing on the right. What did I do on the left side? I'm going to multiply the whole left side by 4 and the whole right side, which means both terms, by 4. But why don't I put it in there? Well, because whenever you got parentheses on the left side here, whatever you do on the outside will eventually distribute in. You really have done it to the inside, because whatever happens on the outside of a parenthesis eventually distributes. If you also did it inside, you would end up doubly doing it inside. And that would be wrong. Make sense? So just do it on the outside, it'll carry in. So what happens exactly then? Well, on the outside, this is really a whole number is really over 1. I know you know that. And these will cross cancel. That's why we did it. We wanted that thing to go away, huh? So what are we left with? Just a 1. And so that 1 will eventually carry in. So it'll be x minus 6. The other side, 4x plus 48. Good to there. We got rid of the fractions. Now, what do you do when you got x's on both sides like that?
Get them on one side.
Yeah, just get rid of one of them. It doesn't really matter which one. You could subtract the x or the 4x. It's good either way. Maybe I'll just do the x. Just get rid of one of them. You don't want 2 of them. Always doing the same thing to both sides, because if one side was bigger than the other and you treat them the same, it'll still be bigger.
Now I would subtract 48 from both sides.
Yeah, so we got minus 6. We've got, was that 3x? Because that was 4x minus 1x, right? 3x, yeah. Now you just got to get x alone. Here's the wall. X is saying I want to be alone. So we say, okay, subtract 48. That's gone. What do we got? Minus 54.
Yeah.
Last step to get x alone.
So it's less than 3x.
Divide by the 3.
Do not flip.
And yeah, don't flip, huh? Because I'm dividing by a positive number, not a negative. So what does that give? Bring it up here. That's minus 18.
Yeah.
These
Less
cancel.
than x.
Yeah, now that's a fine answer mathematically, but the answers on the Math Excel system and the test, multiple choice, will have the x's on the left. So I need to say the same truth with the x's on the left so I know which multiple choice answer to grab on the homework and the test. So how do you say the same thing with the x on the left? Well, you just flip the whole thing around, don't you? That's the same truth, isn't it? How do we know that's the same truth? Well, the x is on the narrow side, the x is on the narrow side. In both cases. X is the lower one in both cases. X is on the narrow side in both cases. So notice x is less. Or you could say the minus 18 is greater. He's on the wide side. He's on the wide side here. He's the bigger. Whatever. We're saying the same truth two different ways. Like if I said, I'm 3 years older than my brother, or my brother is 3 years younger than me. That's the same truth. Said either way. That's what's happening here. Huh? Good on that? Remember all that stuff? Okay, so minus 4 less than 3x minus 6 over 5 less than 0. Okay, so yeah, so this is a triple. It's a compound inequality. It's in 3 sections, left, middle, and right. Basically, it's the same idea. Just whatever you do to one part, do to all 3 parts, and their relationship will continue to be the same. Whichever one was bigger, small, medium, and large will continue to be small, medium, and large as long as you treat them all the same. So, all right, so my first concern is the fraction, of course. I want to get rid of it. What's going to get rid of that? multiply by it. Multiply through by 5, 5, 5. Treat them all the same. Small, medium, large, treat them all the same. They'll still be small, medium, and large. So we get minus 20. What happens in the middle?
You get 3x minus 6.
Yeah. Really, what I've seen over the years, and maybe I should have let you do it before I did it. What I've seen is this. Let me just write it. Let me give you, that's wrong. Don't write that. That's wrong. Does everybody see why that's, I've seen a lot of that over the years. Does everybody see why that's wrong? Because the 5s are supposed to cancel out. Yeah. It's not really there to multiply. It's going to go away. It can't multiply. Make sense? I just see that mistake a lot, though, so I wanted to highlight it for you. So these 5s will actually cancel, and it's just 3x minus 6. And this is 0. 0 times 5 is 0. Is that good on that? So remember to cancel the 5s. That's why we multiplied by 5, because we wanted those to cancel, huh? We wanted to get rid of the fractions. That was the purpose. So don't forget to carry it out. Yeah, so now it's just about focusing on the x right on. So wherever x is, just kind of focus your attention right there. And what is x saying? I want to be alone. That's what it's always saying. So, yeah, we got to add the 6. That's totally right. Let's do that. And whatever you do to one part, you do to all 3, huh? So what's that going to be then? Minus 14. These will cancel. 6. And then the last step, divided by 3, divided by 3, divided by 3. So we get minus 14 thirds. These will cancel. X, and that's 2. You just leave the minus 14 thirds. I think it's multiple choice. No, they want you to type it in. Yeah, how would you type that in interval notation? Would it be parentheses or brackets? Parentheses. Yeah, because there's no bars. Right? So there's no brackets. It's parenthesis minus 14 thirds, comma 2. Left edge, right edge. Just like that. They want you to leave fractions. You can tell. See the blue line? They tell you what they want. Sometimes they want decimals. Usually they want fractions. It says use integers or fractions. Notice, no decimals, notice. So they want you to keep the fraction. Good questions on that? All right. Okay, let me get a fresh screen on that one. 1/5, x plus 1 over 7. One-fifth, x plus 1 over 7/8. Okay.
Is that a 7? Under the x plus 1?
Yeah, it is. Okay. Yeah, so we've got to get rid of those fractions. How are we going to get rid of all those fractions? Common denominator. Yeah, and how do you find the common denominator, the LCD? What do? Just multiply them together. Yeah, just take 5 times 7 times 8, 56, 280, I think.
Yeah.
Use calculators, all that stuff. So 280. So 280 is the common denominator. Just multiply those together, and then what do I do with that 280 common denominator? Multiply. Right? Yeah. So we can bring that 280 up and go okay.
What do you have written on the top? Is that like a bracket?
Where's that?
On the top on the right above.
Oh, this is LCD.
Oh, LCD.
Yeah, sorry. LCD. 280, 280, 280. I'm going to multiply all 3 by 280, right? Can you take it from there? Use your calculator for those numbers. So what do you got to do first?
Distribute the 280 to the x element, right?
No.
Okay, just the 1.
No. Remember, that's the mistake we just talked about. First cross cancel. 7 goes into 280.
40.
Oh, yeah. Well, that'll go to both. Yeah, 40 will go to both, yeah. Yeah, so remember to first cross-cancel, right? You know what I'm talking about? This is 280 over 1, right? Whole numbers are over 1. And you're going to go 5 into 280, which is like 56 times, right? And then the 56 will multiply the 1. So you cross-cancel, multiply what's left over. 7 into 280, 40. And the 40 will multiply. And 8 into 280 is that 35. And 7 times 35. Is that good? Everybody see what happened there? It's because that 280 is over 1. 280 is over 1, huh? Whole numbers are over 1, so things in the denominator cross-cancel. I think you can do the rest easy. I'll do it, but let me pause right. And that's the big first step, for sure the hardest part of the problem. Is that making sense? Questions I can answer on that part? So you got to cross-cancel, because the 280 is over 1, and then multiply what's left over. Is that good? Is that okay? And then just the rest is pretty regular, I think. It would just be 56, boom, boom, 40x plus 40, 7 times 35, 210, 245. Then we got the the 3 sections. X is saying I want to be alone, so it's just all the normal stuff. Subtract 40.
You subtract 40 from all 3 sides, right?
Yeah, whatever you do, you got to do to all 3 to preserve the relationship. Yeah. So that's 16, 205, and last step, got to get x alone. Divide by 40. Now those fractions need to be reduced, don't they? So you can divide this one by 4. Oh no, 8. 8 would be better, huh?
Yeah.
4, I'm going to have to then go 2 afterwards. So 8 would be quicker. 8, that'd be 2/5. And this is
Less than or
x.
equal to x.
And this divided by 5, top and bottom, was that 21/8? Is that right?
I thought it was 41/8.
You're right.
2 of 5
You're right.
Because I have my Casio natural.
And there we go. Questions I can answer on that? So common denominator, 280, multiply them together. Find the common denominator, multiply top on that.
Can we just do this the whole semester, please?
And they don't want us to have a common denominator at the end. It's just the simplest form, right?
Oh, right, just simplest form, exactly. Just simplify them as much as you can, right? Okay. Okay, so let's talk about absolute value. Okay, so now you guys know about absolute value. I'll come back to that problem. But let's just think about absolute value for a minute. You know like absolute value -3, right? What's absolute value -3?
3.
Just plain old 3. And what if you put a number that's already positive in there? Just stays positive. Simple, right? Absolute value just makes things positive. They're already positive, just leaves them alone. What could be easier? Yeah, but it gets a little tricky. Let me show you what I mean. When you stick an x in there, it gets a little more involved. Think with me for a second about what's true. If you do less than or equal to, and then over here, I want to do absolute value of x greater than or equal to 2. There's actually a big difference between absolute value less and absolute value greater. It means two very different things. So how so? Well, let's follow the logic, and then we'll have a rule that we can follow even when things are bigger. So what do I mean? What could I put in there for x? What could x be that would make that statement true? What would make that statement true? I could put in 0, huh? 0 is less than or equal to 2. I could put in 1 or 2. Either one of those is less than or equal to 2. Could I do any negative numbers?
All of them.
Negative 1. Yeah, if I put in negative 1.
That's less than. Oh, but the absolute value.
Yeah, so we're sticking them in for x, but then the absolute value does his thing to them, right?
So it could be negative 2.
So the absolute value of negative 1 is 1, and that's less than or equal to 2. That works, huh? Negative 1 works. How about negative 2? Does that work? Yeah. If you put in negative 2, the absolute value would be regular 2, and that's less than or equal. It's equal. So that's good. But what about like negative 3?
No.
That's not going to work, is it? If you put in absolute value of negative 3, that'll be regular 3, and that's not less than 2. So these are the only numbers that are going to work. And the decimals in between them, like 1.5 and 1.3 and, 0.9, whatever. All the numbers between negative 2 and positive 2 will make that true, won't they? Now let's go to the other side and think about what makes the greater than. So that was less. That was absolute value less than 2. Now let's do absolute value greater than 2. What could I put in there that would make that true? Let's talk about positives first off. I could put in 2, because 2 is equal.
3.
I could put in 3, 4, on you go. Anything 2 or bigger is for sure good. We'll look at negatives also, but so far so good. If I put in any of those, they're bigger than 2. Yeah, good. Now, could I put in like 1? No, that's not greater. Or 0? Or negative 1? No, none of those are greater than 2. Could I put in negative 2?
Yes.
Yeah, negative 2 is okay. Because if I put in negative 2, is that great? Yeah, that's 2, and 2 is greater than or equal. It's equal. So negative 2 works. How about negative 3? Does negative 3 work?
Yes.
Yeah, if you put in negative 3, the absolute value is positive 3, and that's greater than 2. So negative 3 works. How about negative 4?
Yes.
Yeah, you get the idea, right? Negative 4 is 4. Absolute value is 4, and that's bigger. So notice what works is 2 or bigger or negative 2 and smaller. 2 or more negative. In fact, let's put them on a number line. I think seeing it is helpful. So what we're seeing, is a crooked line. What we're seeing is it's all the numbers negative 2 on down, positive 2 on up for the greater, but for the less, over here on the less, it's actually the numbers in the middle between negative 2 and positive 2, isn't it? Two very different answers. The greater goes off to the right forever. What do we call that? Infinity. And off to the left forever. Negative infinity. The greater has 2 intervals. The less has 1.
Then you put the U in between.
Yeah, we'll get to that. Is that logically making sense first off? We're observing what's true. This is how math works. You observe what's true, and then you write a pattern, and then you just always follow the faithful pattern. Even when they make things big and ugly, you just follow what's true, and you're good. So does everybody see that is true? Right? So absolute value less works for numbers between negative 2 and positive 2. All the numbers between negative 2 and positive 2, the absolute value of them will be less than or equal to 2. For absolute value greater, all the numbers 2 or bigger or negative 2 and smaller, like negative 2, negative 3, negative 4, the absolute value of those will be positive 2, 3, 4, which is bigger than 2. It's true, isn't it? So notice the greater has a greater number of sections. That helps you remember. This would be the kind of thing you want to put in your 3x5 card. This would be like probably one of the best things. You get for your 3x5 card for our exam, you can put anything you want on there. This would be a good thing to put. Well, in a minute I'll clean it up even more, and that'd be most helpful. So, what do we see? Absolute value greater has a greater number of sections, 2 sections with infinities. Absolute value less has a less number, just 1 interval, 1 chunk of numbers. Instead of the 2 outsides for greater, for the less, it's 1 chunk of numbers in the middle. Okay? So what I really want to do is be able to say this with an X. So let's bring that into the game now and say, okay, how would you say this with an X? How do you say all the numbers between negative 2 and positive 2 or this interval? Well, that would be 1x, right? Because the X is the shading. The shading is the middle between negative 2 and positive 2. How do you say this one? The x is here and it's there. The shading, the x is in two places, so there's going to be two x's. The x is less than or equal to negative 2 or greater than or equal to positive 2, isn't it? See how the x, the shading is less than left of. Remember, less is left. Lesser numbers go to the left, the negatives, don't they? Left of negative 2 or right of positive 2, greater than positive 2. For the less, the x is in the middle between negative 2 and positive 2. The shading is in the middle. So again, less has less, more has more. Greater has two x's, two shading chunks. Less has one x in the middle, one shading chunk in the middle. That's what's true. So, having done that, we would like to generalize this to work for anything. They're not always just going to put a simple x in there, right? They're going to put something more fancy than just a simple x. But it doesn't matter. If you understand the logic, you're like, that x, what are we doing with x in math? It could be anything, huh? X means put anything here. And here's what you do with it. So, I could, instead of x, I'm going to call this inside. Because that might make more sense to you. Whatever's inside the absolute value, the inside will be between negative 2 and positive 2. However big or fancy, instead of a simple x, it might be 7x plus 32. Whatever. Whatever's in that absolute value, whenever you see a rule in math for x, that x could be anything, right? It's just a placeholder. It's just holding a spot. It's saying whatever's in there, this is what you do. This is what's true of it. So let me write the rule now. So here's the rule. When you have absolute value, let me just summarize what we saw. Absolute value of inside less than or equal to any number. I'm generalizing now. Instead of a 2 and an x, I'm saying anything inside and any number. What do you do? What do you do with absolute value? And then over here on the right side, I'll do absolute value of the inside greater than or equal to a number. Right, that's the difference, right? The less or the greater. Well, what did we see? Let's look back at the pattern. When it's less, you do the negative version of the number and the positive, or it's a positive over there, huh? And you stick the inside thing in the middle, don't you? That's the pattern. Math is patterns. It's all logical patterns. That's all it is. Let's go do that then. So I take the negative version of the number, put the two symbols this way, put the inside here, and the positive version of the number there. Right? Isn't that the pattern we saw? So it doesn't matter how big and fancy that thing in the middle is. That's what's true. And the rest is easy. It'll end up being something comma something. Why? Because that's what it, or parentheses or brackets, whatever. It'll be parentheses or brackets. So I'll make brackets, whatever. It depends. If they have the bar in the beginning, then there'll be brackets. If they didn't have the bar, it'll be parentheses. But it'll be two numbers. The other side, what happens on the right side, the greater side? Let's look back. What's the pattern? You do the negative version and the positive version, and you do the inside in two places. Because this could be the inside, it could be anything. And you do less than the negative, greater than the positive, two separate statements. Greater has two of them, a greater number, right? So I take that inside and I go, inside, you are less than the negative, oops, kind of scribbly there, less than the negative, or inside, you're greater than the positive, right? The negative, the positive. And then you just solve them both. There's two of them to solve there. Greater has a greater number. And then the answer ends up being negative infinity comma something. United. The U just means unite. Just put them together. It's nothing fancy. Something comma infinity, right? We always end up with infinities on the greater. You have the infinities because they go off left and right forever. They're the two outsides. So there's the yellow brick road. That's how we get to the wizard. That we just follow that road, right? That's math. That really is. I mean, if you can dial into that, the more you can dial into that, that's what's going on in math and science. They make a logical observation. They go, here's the pattern. Then they give you a bunch of problems, and you follow the pattern. Math is about learning more and more to recognize patterns, predict patterns, describe patterns, and follow patterns. That's all math is patterns. All right, so let's try it on actual problems. So that's what I would probably put on my 3x5 card. That right there, maybe, or maybe an actual example would be more helpful for you. Whatever. Let's do. Here we go. So absolute value for x less than 4. Okay. So let's follow the pattern. See if you can do it. Let me give you a try. See how good you are at following that pattern. Decide which side it is, left side or right side, and then try to real carefully. Just do the first step. That's the most important. The rest is normal. But the first step is the strange one, the new one. Okay, so let me look back to the pattern. Is it left side or right side? It's less. And by the way, the bar, there's no big difference there. If they don't have the bar, then there's going to be parentheses instead of brackets. That's all that affects. So less, it's this left side, isn't it? So it's this one. What do? You put the inside in the middle, put the negative and the positive.
So -4 is less than...
Okay, so let me try it. So here we go. So you put the -4 over here and the +4 over there like that. And they're both less than. See how they're both less than? Because that's the small, the medium, small, and large. That's how they always, whenever you do the compound, it's both less than. Now, I've done it wrong, and I hope you see that I've done it wrong.
You need to divide by 4.
Oh, I'm not done. I mean, I got more steps, but even this step is wrong. Can we hold on just a minute and I'll finish up with you. So it's wrong. What's wrong? What's not true? I know there's more steps, but not just that. There's something currently wrong.
Whenever you plug in any numbers from that, like positions you put in, it's just going to make it greater because there's 4 right there in front of it. So like if you were to plug in like -3 into that, you'd get -12, but absolutely becomes 12, and 12 is not less than 4.
Right, but some things are true, like 0 works.
Well, yeah, but like it's not completely true. I don't know how to explain.
Yeah, what have I done this? I didn't follow the pattern. I'm close to it, but I wasn't precise enough. And I write this because I see this all the time. This is the mistake I see. Let's look back. Well, why is this not quite the pattern? Look back. Here's the pattern I'm supposed to follow.
Just what's inside the absolute value?
Yes, in other words, what's not supposed to be there?
The absolute value.
These. And that's not decoration. That matters. They're off. That's the whole point. I see that mistake a lot, so I wanted to highlight it and make it and talk about it. Does everybody see that? The first step has the absolute value. The second step, they are gone. And they need to be. Otherwise, what you're writing is logical garbage. They're gone. It might not seem that way to you if you're still a little bit more on just the visual end of it, but it's not true if you have the absolute value still there.
It'll make it all positive.
Yeah, that means all positive. That's just a crazy statement.
Yeah.
You got to remove it. Everybody's seeing that, right? This first, I want to really emphasize that because that's the mistake I've seen over the years. This first step is the removal step. We're trying to correctly remove the absolute values, aren't we? See how they're here on the first step and then they're gone. That's the whole point. We're trying to learn how to correctly and logically yank them up. Like, look back to our beginning logic. Remember back when I was here and I said absolute value inside, and I said that what if I'd written absolute value still here? Absolute value of x, well, yeah, of course it's bigger than negative. Oh, and that's just a silly statement, right? They've got to be removed at that point. Everybody seeing that? Really important. So now it's good. Now it's all good. Now, how do we finish up? Now it's easy. Once you've removed them correctly, that's the first step, is correct removal. It's all simple and easy. What do I do to get x alone?
Divide by 4.
Divide by 4. That's all. And once they're out of there, it's easy. So there it is. Got it. Parenthesis, -1, 1, done. Now it's true. That good? Now you might have left them on there and still got that, but that in-between work would be logical garbage. You don't want to do that. Let's try another one. Okay, so in fact, let me just get fresh room here. 21. Absolute value 5x greater than 10, is that what it says? Yeah. All right, try that one. So follow the pattern, which means first step, you're going to yank them off, huh? You're going to remove those absolute values and then follow the pattern. Is that going to be left side or right side? Which one does that, on the two patterns? That's greater. That's the right side, huh? That's going to break into two x's, isn't it? Right? Greater has more. I wasn't sure if you guys were coming, so I went a little slow. If you don't mind. Because I actually talked about it already. So, do you want to just pass it out real quick? Sure. Do that. You can just take my pass down and I'll be ready. And another one. Okay, so first step is correct removal. So I'm going to remove these absolute values. And when I do, what's the pattern for greater? Let's look back. For greater, it breaks into two separate statements.
Inside is
Right? Inside less than the negative, you can't turn those symbols. It means something totally different the other way. And inside greater than the positive. So I take the inside less than the negative version of the number, or the inside greater than the positive version, huh? See, that's the pattern? We good there?
Mm-hmm.
And the rest is easy. The rest is just stuff you can do in your sleep, right? It's all about that first step, correct removal of the absolute value signs. And so now it's easy, just divide by 5. X is less than negative 2, divide by 5, x is greater than 2. How do you write that? Remember, this always has the negative infinities and the positive infinities, right? It has the two separate. Remember, greater has a greater number of answers. Absolute value greater has two x's, two intervals with the infinities.
So always be infinity.
Yep, always be. Because it's always the two outsides. Remember us logically reasoning that if you were greater, it could go down to negative numbers or up to positive numbers. Does that make sense? And the absolute value less has just one x and one interval. Has less answers, doesn't it? Is that making sense?
Yeah.
We're good on that? Questions on that one? Let's do one more. Like as far as, yeah, because here it's greater and then I made it less. Is that what you mean? Yeah. Like I switched it. No, he's exactly right. Does everybody see that? See how this sign is going the opposite direction of that sign? My answer is because that's what's true. Remember, we reasoned it. So not because divided by negative or anything like that. Remember back when we first reasoned out, we said, what does it mean for absolute value to be greater than 2? What does that mean logically? You can be 2 or bigger, or you could be negative 2 or smaller, like negative 3, negative 4. The absolute value of negative 3 is bigger than 2. So that means you could be numbers less. See how that's turned from that? Because that's what's true. If the absolute value of something is bigger than 2, that means the thing itself can actually be less than negative 2 or greater than positive 2. That's what's true. If that isn't quite hitting, a lot of times math teachers would tell me stuff and it just wasn't hitting right away. That's okay. Keep working with it. It'll sink over time, but at least follow the yellow brick road. What's the yellow brick road? That is turned. See how the pattern says you take it and you turn it. So at least if all the concepts aren't hitting you right on, that's okay. That'll come in time if you keep working at it. But at least follow the pattern precisely, which means turn it and keep it the same. Right? That's what the pattern says. Got to have that. And you can put that in your 3x5 card. All right, so let's try. All right, where were we? I lost the problem. Was it this one? I don't know. Let me see. Yeah, that one. There it is. Okay, so let's do this one. We'll finish with this one. I'm going to make that an X because my T's look like plus signs, and it doesn't matter if it's what the letter is anyway. So there we go. That's a absolute value bars. So absolute value 5x minus 1 less than or equal to 7. So now, notice we have a bigger expression. It's not just a simple X. But whatever. Who cares? Just follow the same pattern. It'll all be good. So which of those two patterns is it? Look back. It's the first one, right? The one on the left. Look at which way those symbols are facing. That matters. So the first step is the most important. It's the removal step. So I'm going to remove it, and then what do? What is the pattern? Let's look back at the pattern. What does the pattern say? For absolute value less, you remove it, you put the negative and the positive, and both symbols are less than, aren't they? See the pattern? Both symbols are less than, negative and positive. So I'll do the same thing. Both symbols are less, negative 7, positive, right? It's the negative, it's the positive. Everybody see that pattern? The rest is easy, right? Just add the, I'm going to go da, da, da. You can do the rest, right? I want to do actually one more because the rest is easy. I want to show something else harder. Everybody see that pattern? Where's this last one? Was absolute value greater? What's the pattern there? You turn it less than the negative, greater than the positive. Because that's what absolute value greater means. You're super small or super big. Less than the negative, bigger than the positive. That's logically what that means. Okay, so let's try this one real quick. Kind of running out of time.
Aw.
So, all right. So I just want you to, well, I'm going to do all of the steps, but especially the first step. I'm sorry, guys. I'm using both my eyes again. Do this a little bit. So, hey, while you're doing this one, let Wendy say a couple words here real quick. Real quick, we're out of time. What do you do for greater? Less than the negative? Or greater than the positive, and da 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 da. You're going to have to flip the symbol with the negative and all the rest. Everybody good with that? Everybody following that logical pattern?